So let's try to solve this problem. It's a very easy problem. Detect a cycle in a linked list. So basically it is given as given at the head of the linked list. Determine if the linked list has a cycle in it. So there is a cycle linked list. So what is the definition of cycle? It is given here. So basically cycle. So basically if we call what is cycle, one node, two node, three node, four node, and if we join with any of the node, any of the previous node, it contains basically a linked list which contains cycle. So it does not have null pointer. It does not have null pointer. uh, for this it is having pointing towards any of the previous node. It can be 3, it can be 2, it can be 1. So how to detect a cycle for in this linked list? So for that we are basically have two two methods for this detection. First is using hashing, and another one is using two pointer two pointer approach. Okay, so using hashing, basically its time complexity is big of n and space complexity is big of n, sorry. And in hashing we basically used to store addresses and check check whether the address is already present in the hash table or not. Suppose we are at this node, so we basically stored the address of the next node. So suppose the address of the next node is, wait a minute, let me do, yes. So suppose if the we make a hash table, let me draw here 2, 3 and 4, and it contains a loop. We make a hash table. This is our hash table. So it contains all the addresses of the next pointer. Suppose we are at here, so at this point the address of the it contains the address of the next pointer. Suppose the address of the next pointer is 2000. So then suppose the address of the next pointer is 2000, mark it as red. And when we move our pointer to next node, it contains 3000. So we again fill our table with next address 3000. Again it move 3000. Again it contain address of the next node which is 4000. So again it fill 4000. It will check whether the 4000 is present or not. Okay, again this node, it contain address of the second node which is in this node. So the address of the second node is already present in the first node, it is 2000. So it points to 2000. Again it check, and we found that it is already present, which is 2000. So if we found any address which is equal to present at which is equal to address that is present in the hash table, then we will call it has a cycle. Simple. So it takes space complexity of big of n. So we don't want this big of n space complexity, so we follow second method. In second method we usually use two pointers. Suppose we have a linked list 1 2 3 3 4 5 6 7 8 9. Suppose we are having this linked list which containing a loop. Okay, so we need two pointers. First pointer is a first pointer, basically it is a slow pointer, we can say slow pointer. And second pointer is our fast pointer. So what does it mean, slow and fast? S- Slow and fast. Slow pointer move one step, while the fast pointer move two step. This is the main key point. So slow move one and fast move 2 points. So if we check our both initially our both pointers our both pointers pointing towards head of the linked list. So here we can see a dry run, slow pointer, suppose it is a slow pointer, and it is a fast pointer. Slow pointers move one step ahead. So suppose I am incrementing with one node. So our slow pointer moves here. So now slow pointer, red one is slow pointer and white one is fast pointer. Now we take a fast pointer, we will increment it by 2. So now 1 2, it will points to the third node. Again we will follow this rule, we will increment this pointer to +1 and we will increment this pointer to +2. Here it is and it will go here. It is a slow pointer, it is a fast pointer. So after that we will check if slow is equal to fast or not. Or basically we can, yeah, slow equal to fast or not. If it is equal, then it contains a loop, the terminating condition, which is this is the terminating condition basically. So now again we follow our diagram. Now slow pointer move +1 and fast pointer move again +2. So slow pointer it is here. Now we can move it to fourth fourth node, and our fast pointer is here, fifth node. We can move it to this seventh node. 5 plus 2, seventh node. Again we do this. Our slow pointer move from here to here, +1 increment, and our fast pointer again move to 2 pointers ahead. That is 9. Our fast pointer. Again we move our second point slow pointer one step ahead, which is 6. This is our slow pointer. and fast pointer plus 1 and plus 2. Fast pointer, again it's not at this position. Initially it is at 9. If we increase it by 2, then it comes to the 6th node. Since both the pointers are pointing towards the same node, so it detects a loop and it terminates the condition while exiting. It is a true that this linked list contains a loop. So basically, if does not have any loop, suppose it does not have any loop, suppose we break loop here, so it does, our fast pointer does not jump to 6 pointer. So basically our fast pointer does not jump to the 6 pointer because it has no connecting address. Basically connecting address towards its 5, basically it's pointing to null, so it is pointing to null, so the fast pointer does not move, it points to the null. And while our second pointer travels to the same node and it also points to null. So basically if we got a null value, then it does not contains any loop, not a loop, not a loop detected. So now let's code it. So here it is given. First of all, we make a to loop. First of all, return the head. No, return the false statement. Basically, didn't detect any loop. Then we make a fast pointer, fast and slow pointer, that is list node, list node start, slow pointer, which is pointing to the head. Same with the fast pointer, list node star fast, which is also initially it's pointing slow pointer and it is a fast pointer. So here we make a loop while our fast is not equal to null, and you double L null, and our fast next should not be equal to null. If it is null, then our loops break, and it if we does not get any loop, if we didn't find any loop, it terminates. So now what is the base condition? First of all, we have to increment the pointer, so slow pointer equal to slow by next, and fast pointer is equal to fast next to next. Increment by 1 by 1, and it is increment meant by 2. Simple. Now if our slow pointer equal to fast pointer, if it is meet, then return true. Simple. That is, both the pointers meet. Let's check whether it is running or not. Yep, it is running, so we can submit the code. Yep, it is so submitted. So thank you.